In the previous lesson, you learned 3 methods of combining data vertically: appending, concatenating, and interleaving. In this lesson, you learn to combine data horizontally by merging data sets. When you combine data sets horizontally, you combine the observations from multiple data sets into a single observation in a new data set. In this lesson, you learn to combine data horizontally by merging. When you combine data horizontally, it's important to ask the question, what is the relationship between observations in the input data sets? The observations can be related in several different ways. In a one-to-one relationship, a single observation in one data set is related to one and only one observation in another data set, based on the values of one or more common variables. For example, suppose 2 data sets contain employee identification numbers for the same group of employees. Each employee ID number appears once in each data set, and each observation in one data set has one matching observation in the other data set. In a one-to-many relationship, a single observation in one data set is related to multiple observations in another data set. In a many-to-one relationship, multiple observations in one data set are related to one observation in another data set. In a many-to-many relationship, multiple observations in one data set are related to multiple observations in another data set. Sometimes, the data sets have non-matches. At least one observation in one of the data sets is unrelated to any observation in another data set based on the values of one or more common variables. Later in this lesson, you'll learn to combine data sets that have all of these relationships. Now, let's look at how you combine data sets horizontally by merging. Merging combines observations from 2 or more SAS data sets into a single observation in a new data set. You can merge observations based on either their positions in the original data sets or by the values of one or more common variables. This lesson focuses on merging based on the values of one or more common variables, a process called match merging. Here's an example of match merging. Suppose you are working with 2 data sets. EMPS-AU contains the first name, gender, and employee identification number for employees in Australia. Phone H contains the employee identification number and home phone number for employees in Australia. SAS can combine observations that have the same value of EMP ID, a variable that is common to both data sets. Suppose you want to combine 2 data sets. The first data set, EMPS-AU, contains the first name, gender, and employee ID number for several employees. The second data set, Phone H, contains the employee ID number and home phone number for the same set of employees. You want to combine these data sets horizontally so that each observation provides all possible information about one employee. Combining data sets in this way is called match merging. Here's a question. Which variable can you use to match merge these data sets? You can use the EMP-ID variable for the match merge. And here's another question. Do these data sets have a one-to-one relationship? Each data set contains the same 3 employee ID numbers. You can use 2 methods to match merge data: the merge and by statements in a data step, or proc SQL. In this lesson, you'll use the data step, but you'll also learn a bit about proc SQL. To match merge using the data step, you use the merge and by statements. You've already used a by statement in the data step to interleave datasets. Whether you're interleaving or match merging, you must first make sure that your input datasets are sorted on the by variables. In this example, the by statement specifies emp ID as the by variable. Fortunately, the two datasets that you're working with are already sorted on the by variable emp ID. Above the by statement is the merge statement. For match merging, you use the merge statement instead of the set statement. In a data step, the merge statement joins observations from two or more SAS datasets into single observations. To combine datasets, you specify at least two datasets in the merge statement. If you specify only one dataset, SAS treats the merge statement like a set statement. In this example, the merge statement specifies EMPS AU and phone H as the datasets to be merged. The by statement performs the match merge by matching observations on one or more by variables. Remember that the by variables must be common to all input datasets.
Now let's run our data step to match merge the two datasets by emp ID. As usual, our program has two steps, a data step and a proc print step. In the data step, the data statement specifies emps AUH as the output dataset. The merge statement lists the two datasets to be match merged, and the by statement specifies the by variable emp ID. We know that our datasets are already sorted on emp ID, so we can run our program. The log shows that our step ran successfully. Notice that SAS read 3 observations from each of the input datasets and created a dataset that has 3 observations. Our proc print output shows that SAS combined the observations by matching employee ID numbers. The first 2 variables came from the EMPS AU dataset. The third variable, the by variable, is common to the 2 input datasets, and the last variable came from the phone H dataset.
Now, try practicing in your Suppose you want to combine 2 datasets that contain information about employees in Australia. EMPS AU contains first names, gender, and employee ID numbers. Phone HW contains employee ID numbers and both home and work phone numbers. You want to match merge these datasets based on the common variable EMP ID. You assume that the same employees are listed in both datasets, but it's a good idea to examine your data first. Here's a question. What is the relationship of these two datasets? These datasets have a one-to-many relationship. The same employee ID numbers are listed in both datasets. EMP's AU has one observation for each value of EMP ID. Phone HW has two observations for each value of EMP ID, one for the home phone number and the other for the work phone number. Your output dataset, which you'll name EMP's AU-HW, will have two observations for each employee. To match-merge these datasets, you write the same kind of data step that you wrote before. The data statement identifies the output dataset as EMP's AU-HW. The merge statement lists the two input datasets. And the by statement specifies the by variable EMP ID, which SAS uses to combine the observations. All observations that have the same value of the by variable are in the same by group. Here's a question. In EMP's AU, how many observations are in each by group? In EMP's AU, the EMP ID values are unique, so each by group consists of only one observation. Here's another question. In phone HW, how many observations are in each by group? Phone HW has two observations for every value of EMP ID, so each by group has two observations. Let's see how SAS processes this data step when the datasets have a one-to-many relationship. The compilation phase has just ended, and SAS has created the PDV as well as the descriptor portion of the output dataset. The output dataset isn't shown here. You'll have a chance to see it later. The PDV has 5 variables: first and gender from EMP's AU, EMP ID, which appears in both datasets, and type and phone from phone HW. To start, SAS sets the values in the PDV to missing. SAS also assigns a tracking pointer to each dataset that's listed in the merge statement. Now, at the start of the execution phase, SAS is ready to combine observations. SAS looks at the first by group in each of the two datasets to determine which by group should appear first in the output dataset. Here's a question. Are these observations in the same by group? These two observations have the same by value, so they are in the same by group. The data step reads the values from the two datasets into the PDV in the order they appear in the merge statement. The PDV now contains data for Togar's home phone number. SAS then writes the contents of the PDV to the output dataset as the first observation. SAS is now ready to start another iteration of the data step. At the beginning of each data step iteration, SAS reinitializes variables in the PDV. In this example, SAS retains the values of all variables in the PDV because the merge statement read the values from existing variables in the input datasets. However, if the data step had an assignment statement that created new variables, SAS would reset the values of the new variables to missing in the PDV. SAS now moves the tracking pointer down to the second observation in each dataset. Then, SAS checks to see whether these two observations are in the same by group as the data that SAS read in the last iteration. Here's a question. Does either of these observations have the same by value as in the PDV? The observation in EMP's AU has a different by value. This observation is in a different by group, and SAS will process it in the next iteration. However, the observation in phone HW is in the same by group. This observation contains Togar's work phone number. Now, SAS reads into the PDV the values of type and phone from the observation in phone HW. These new values replace the previous values of type and phone in the PDV. However, the values of first, gender, and EMP ID remain the same as before. Finally, SAS writes the values in the PDV to the output dataset, creating the second observation. Once again, SAS retains the values in the PDV. In MSAU, SAS is still looking at the second observation because this data has not been read to the PDV. However, in Phone HW, SAS moves down to the third observation. These observations are in a new byte group, so SAS sets all the values in the PDV to missing. These observations are in the same byte group, so SAS reads the values from the MSAU observation and then the Phone HW observation into the PDV. Then, SAS writes the PDV values to the output dataset as the third observation. The data step continues executing in this way until SAS reaches the end of file for both datasets. Here are the data step and the final output dataset. The output dataset has 2 observations for each employee. Now, try practicing in your SAS software. Suppose you want to match-merge the datasets MSAU and Phone C. MSAU contains the name, gender, and employee ID number of employees in Australia. Phone C contains the cell phone numbers of employees in Australia. Both datasets are already sorted by the common variable EMP ID. Here's a question. Do the input datasets have any non-matching values of EMP ID? 2 observations do not have matching values in the other dataset. The second observation in MSAU and the third observation in Phone C. This means that we don't have a cell phone number for Kylie. Also, we do have a cell phone number for employee number 121153, but we don't know that employee's name. You want to match-merge these datasets by EMP ID to create a new dataset named EMPS AUC. The output dataset should include only the observations that match across the input datasets. The first observation in the output dataset is shown here. By default, the data step includes the non-matching observations in a merged dataset. However, you can also choose to exclude the non-matching observations. Throughout this lesson, we refer to matching observations as matches and non-matching observations as non-matches. To start, let's see how SAS processes a data step by default when there are non-matching observations. Here's our data step, which match merges these two datasets on EMP-ID and then creates the output dataset, EMPS-AUC. This data step is similar to the data steps shown in earlier match merges. Let's start at the beginning of the execution phase. SAS has already created the PDV and the descriptor portion of the output dataset with the four variables, first, gender, EMP-ID, and phone. SAS looks at the first observation in each dataset. SAS determines which bigroup should appear first. These two observations are in the same bigroup. SAS reads the data from the current observation in the first dataset and then the second dataset into the PDV. Then, SAS writes the contents of the PDV to the output dataset as the first observation. The values remain in the PDV as SAS begins the next iteration of the data step. SAS now looks at the second observation in both datasets. Here's a question. What does SAS look for now? SAS checks to see if the current observation in either of the